Hey, welcome back. We want the tree's movement to be more erratic, so that it will change direction randomly as long as it is within the bounds that we have set up, so within that boundary. This will make the tree's movement unpredictable and thus the gameplay a bit more interesting. For now we are done with the tick function. The tick function is expensive, so we want to use timers where we can. Remember that in most games you will have multiple actors that might call the tick function each frame, and that can add up. So you want to write as little logic as you can within the tick function, especially calling a bunch of functions within the tick. Remember that even a basic function has a slight overhead involved with that. So while we could do some calculations within the tick function to do the erratic movement, that is for the tree to change direction randomly, and also actually with the spawning, as we'll do later on in the lesson. But again, we won't do that in the tick function because we have the timer facility, so we will use that instead. Alright, so I'll go back to the header file here. To get started, we will create a timer. This will be in the private section. This does not have to be in the public or protected sections. Next, we want to declare a function that will be called by that timer. Right-click on this, Quick Actions and Refactoring, and I will select to create a definition of change direction in the treebase.cpp. And I'll just switch over to that CPP file here. You can see we have the body, the definition. Before we go ahead and define that function, I want to set the timer in the begin play. So when the game starts, or when this actor is spawned, we want to start the timer. We call getWorld, which will return a pointer to that. We get the timer manager, and on that we invoke setTimer. We pass in the timer handle. We specify a pointer to the function that we want us to invoke. I'll set this timer to 1 second, and I want the looping to be true. I want a different delay for the first duration so that when this actor spawns or when the gameplay begins, that the player has some time to settle before the tree starts moving, especially when it starts moving erratically. We just want the player to sort of get comfortable in the level before this starts with that erratic movement. I will set that to 2.5. Always remember to add the A, so I forgot that there for a second. That is a tree base, not just tree base. That is an actor. Always remember that Unreal will add the A at the front because that is an actor derived from actor. And that is basically it for the timer. Okay, to set that timer, I will go down to where the change direction definition is and we'll go and implement that. If you want, you can go ahead and pause the video for a second and implement this. Try and implement this by yourself. Alright, I'll just continue here. Remember that if you want to change the direction of the movement of that apple tree, all we have to do is to change the movement speed variable, that is to set it to positive or negative, since that is what we use in the tick function to update the position of the actor in the world. Okay, again we do this right here in the tick function. And we've done a similar thing up here, where we basically modify the movement speed to positive or negative, depending on whether we want to move right or left. So what we can see with this is if the movement speed is positive, then we will multiply that with -1, which will make the movement speed a negative value, meaning that we will change direction. If it is negative, if the movement speed variable is negative, then we go and multiply that with -1, which will set it back to positive again. And for now, just for testing purposes, this is all I'm going to do, and I will build and run this to see what we get. Okay, that build has succeeded and it should now launch. You can use the live coding for this, of course. I'm just typically closing the editor, and the next day I come back and I continue recording. So in that way I open the solution instead of opening the project first. If we simulate now, I'll just click simulate. You will see that it will have some erratic movement, but at this point it's kind of stuck. Alright, especially at the edge there, it will sort of get stuck. Why? Because we only have 1 second in that loop, and there's no randomness to that. So for an exercise, I'd like you to go and fix that. I'll just go and turn off real time here because that is making my fans go a bit louder than usual, go ahead and define some variables such as a chance to redirect a float, and then try and find a suitable function in the fmath library which will allow you to define this behavior to be a bit more random. That is in the change direction function. Okay, back in the header, I will scroll down, and actually if you want with these variables, you can go and set the blueprint. So what I can do is in the U property here for movement speed, for example, you can do blueprint read only or blueprint read write if you want. Same thing with the boundary. We can always come back and make this blueprint read only later on if you want. The artist may want to have access to that to get and to set that within blueprints. So what I want to do next is I'll actually just copy this. We will create a float, a chance to redirect. This is going to be the chance for that actor to move in the opposite direction, or to turn around, or to redirect right. So put whatever comment you think will make sense for you. Then I'll actually go and declare another float. I'll just call that redirect time. Copy that. And then I'll go and set that here in the get world get timer where we set the timer. But before I do that, of course, I want to go and initialize that. First, we want to initialize the chance to redirect. Then I want to initialize the redirect time. This again is just to give the artist some ability to go and modify that if they want. And then I'll use that redirect time where we do the timer in the begin play. Instead of this value right here, this float, I will pass in the redirect time. Now you can also go and create a variable for this initial time if you want to do that. We may do that later on, but for right now it's not necessary. I'll just continue on here. And then I want to do a check. I will surround the statement with an if statement, so we can do a check. I will use fmath. Then you can search for something like rand, and this is going to return a random integer between 0 and rand max. You can also do some seeding and stuff, but we don't need that for this particular logic. This is what is really useful about using floats. We can use frand, and if I do Ctrl-K, Ctrl-I here, that is going to return a random float between 0 and 1 inclusive. So with this, we are going to change the direction. The artist can also change the chance to redirect to change how random that redirection is. That is how often the tree actor changes direction. This is going to be the first level that the player will experience, so we don't want the movement to be too erratic. We want the player to get used to the game and be able to finish the first level relatively easily before moving on to more difficult levels. But again, with this we give the artist the flexibility to change the randomness. With that set up, I will compile the build succeeded and we can see what we get. I will start simulating. And you can see that the movement is now a bit more unpredictable. It's not going to redirect every second. Sometimes it does not redirect at all. Alright, you might notice some buggy behavior right at the edges there. We will fix that later on in the lesson. That is going to wrap up this lecture. I'll see you next time.